Okay guys, in this section we are going to learn how to build a dark sensor circuit. Dark sensor circuit. Okay, so first question is, what is dark sensor circuit? This is a special type of circuit which show always reaction in the presence or absence of the light. Let me clear these things. Suppose this is a dark sensor circuit and it has an LED. Okay, LED. Now if we take this circuit and keep the dark place or absence of the light, the LED will turn on, and if we return back to the light state or presence of light, the LED will turn off. This is simple, but first we have to know what is voltage divider rule. Before going through the main topic or before going to the main tutorial, this is very important to know about this voltage divider rule so that you can easily understand or easily implement this circuit. Okay, for example, suppose this is 5-volt power source and here we connect two resistor in series in this circuit. Okay, so suppose it is 5-volt source and this is 1 ohm resistor and this is 4 ohm resistor. Now tell me how much current will flow in this circuit. If this will be I, then what is the value of I? Simple, we know V is equal IR, it is Ohm's law. Then if we take I over here, then I will be V divided by R, and then V5 R equal 1 plus 4 ohm, right? So this will be 1 ampere. So 1 ampere current is flowing all over the circuit. Now if you want to calculate the voltage across this resistor or 4 ohm resistor, how much is it? Suppose it is V2. Okay, then what will be V2? V2 is nothing but V equal IR2. Here IR2 equal 4 ohms. So we got V2 equal 1 into 4 equal 4 volt, right? So you can easily understand that our main source, our main voltage source is 5 volt, and 5 volt is further divided into two parts. First part, here this is 1 volt and it is 4 volt. Okay, it's clear why 1 volt, because 1 into 1 equal 4 volt, 1 volt, sorry. So if we use 5 volt power and if you connect 1 ohm and 4 ohm resistor in series of the circuit, then you will get two values or two voltage. First voltage 1 volt, that is the dropped voltage across the 1 ohm resistor, and 4 volt, which is dropped voltage in 4 ohm resistor. And now just consider on resistor is fixed, it would be 4 ohm resistor or 1 ohm resistor, no problem. So let me redraw this circuit again so that you can understand more clearly. Okay, so this is the two resistor and this is the voltage level. It is 5 volt, it is 4 ohm, sorry, it is 1 ohm and it is 4 ohm, right? So suppose I just take the resistor and keep it as constant, we never change it, but somehow if we change the resistance, not resistor, resistance, okay, resistor is just a physical material and resistance is the property of this material, simple. So if somehow if we can change the resistance, then you will get a variable voltage here. Any doubt about that? I think not. So if the voltage would be 0 volt, when 0 volt, if the resistance will be 0 ohm, then you get it is 0 volt, right? So then this 5 volt, if we just take the voltage in the across of the resistor, you will get total 5 volt here. So if we fixed on resistance or on resistor first of, then since the resistance of other resistor, then you get the variable voltage. And taking the variable voltage, we can easily calculate how much the resistance is. So if this will be not constant, it is variable resistance, and always read this voltage and you can easily understand what is the resistance over there. Okay, now a big question arises: which component show this property? And since our intention is to build a dark sensor, so we always focus to the light, presence of light and absence of light. We have one component, this is LDR, this is a LDR. Okay, LDR means, let me change the color, LDR, this is light dependent resistor, light dependent resistor. What is that? This is a resistor. In a simple word, it is resistor, but it has some special property. It changes the resistance. LDR changes its own resistance according to the falling light. Okay, I repeat, LDR is a resistor which always changes its own resistance when it is always dependent to the light. Let me be more clear. If more light on this LDR, then you get low resistance. Okay, and less light, obviously high resistance. Okay, simple. Now redraw this circuit connection, and now I am using LDR. So what will be the circuit connection? The simple. Here we use LDR, then in this section we use a static or constant resistor, and here we apply voltage like 5 volt, since we use the power source of our Arduino, and our Arduino is 5 volt source, as 5 volt source. So here we connect 5 volt source, and here we connect ground, and if the center tapped here, and here we connect our analog input pin. Remember that analog input pin which are A0 to A5. You cannot connect the digital pin. I repeat, you cannot connect with the digital pin, because digital pin only used for write and read the digital signal. Okay, either it is 0 or on. And when you want to read the voltage or variable voltage like intensity of light or something like that, then you cannot use the digital pin. Digital pin always used for write digital voltage and always read the digital voltage, nothing else. So if we connect this terminal or connect this pin to the digital pin, then you cannot get the proper result. So always try to remember, analog type signal is always for analog input pins, and it is A0 to A5. This is a special pin, so always connect the A0 to A5 pin. Okay, so if you have question that okay, then fine, if I connect like that, so there are any problem? Answer is no, no problem. Okay, so you can use any circuit, just simple circuit. Now let me connect these things. I am using this connection, you can use this also, but here I am using this connection. And take the reading. First of all, we should read the readings according to our darkness and light. Okay, so light and bright state. First of all, we define this value and make a threshold level, and rewrite that program as in when it goes below to the our threshold voltage, we will consider it dark condition, and if the voltage level is go over to the threshold level, then we consider this is light condition. Okay, and then we connect a LED. So LED connection is simple as previous. Okay, there is no a special connection, a simple connection. And we final state, we write another code where we take a condition. Condition means like if the voltage level is go above to the threshold level, then if we consider this is bright state, so turn off the light or digital light LED low. And if we if the voltage, if the readings of here, I mean I have always telling about this reading of here, and reading is will below to the threshold level, then we consider this is dark level, and we turn on the light. Okay, so let's start with some basic circuit connection. Okay, this is our blank breadboard, and this is our Arduino. First of all, we connect the power rail of the breadboard to the power connection of 5 volt of the Arduino. So you can take this pin as your power pin in your circuit. So this is our main component, LDR, light dependent resistor. So according to the discussed circuit, I arranged the circuit diagram. So I connect one pin of the LDR to the positive rail of the breadboard, and other rail goes to any pin of the breadboard. Then take a 10k resistor, then connect the other pin of the LDR and ground rail of the breadboard. Okay, fine. Then take a another jumper wire and connect the junction connection point of LDR and resistor, and other pin goes to the any analog pin of the Arduino. Here I am using pin number A0 to the Arduino. Okay, now next, done the same things as previous our LED connection. Just take an LED and connect the shorter side or negative side to the negative rail of the breadboard, and positive rail goes to the any pin of the breadboard. Okay, then connect a 220 ohm resistor to the positive side of the LED, and other side is goes to any other pin, any other hole of the breadboard, and take a another jumper wire, and I am connecting it to a pin number 7. You can use any pin, I told you before. Okay, this is the connection. Now write a simple code and fixed our threshold value, so just check it carefully. So first of all, define two variables for LDR, which is connected to L0, and LED, which is connected to pin number 7. Then in setup section, we just define our LDR pin as an input pin, and the LED pin as an output pin. Okay, then in the loop section, first of all we just want to see the result, or the value or the voltage level in the pin number A0 or LDR. So we can write analog read LDR, but we have to need a display where we can see the value. Since we don't use any display, we can use the serial monitor of Arduino IDE. Arduino IDE provide us a very good monitor where we can see the result, or we can communicate with the Arduino through it. So basically, serial monitor is a communication medium between our computer and Arduino. Okay, here you can see this is serial monitor. This button is for serial monitor. When I hit the button, you want to see no not connected, select a board and port to connect automatically. Okay, so if you want to use this monitor, first of all you have to connect the Arduino first, and not only that, but also define the serial monitor first and the baud rate, like that. I just write serial begin 9600. That means this line execute when this line will be executed, a serial monitor open which has baud rate 9600. Okay, it's simple. Then we can use easily the serial monitor. There are many types of baud rate, but 9600 is standard rate for our Arduino. Okay, now if we just print this value, you can simply write serial.print new line. ln means new line. Okay, then this value we some delay over there, like 50 millisecond, no problem. Okay, this is the simple code where we want to basically we our intention is just take the threshold value or fix the threshold value. Okay, then if we just read this code, then first of all we just define two variables, which is for LDR and LED. Then LDR is input and pin LED will be the output. We also use the serial monitor of the Arduino IDE. That's why we write serial begin 9600 is the baud rate. Then in the loop section we just serial print. That means we just print this value in our serial monitor, and the value is analog read LDR. So this function will give a decimal value of the voltage drop that in the LDR pin or A0 pin. I just told you before, a A0 pin or analog read pin is used for reading the analog value. So first of all connect the Arduino board to the uh, our computer, then select the port and board. After the selecting, then upload the code. Okay, here is a problem. Input, sorry, in not input, it's input. Okay. After hitting the uploading button, the code successfully uploaded. Just a little bit wait. Okay, done uploading. After uploading this code, if we want to see the voltage, this is the voltage level. Okay, this is the voltage level, or basically it is the decimal value of decimal representation of the reading voltage over the A0 pin. Now this is the light condition where you get the value approx 750 50 or 750 something below over it, and when we just cover the sensor, we get less amount of value like 65 66 like that, and just cover with one finger of my hand, then you can see there are 270 or something like that, and after uncover the sensor we get the result of 27 to something like that. Okay, fine, no problem. So if we just fixed our threshold value at 300, we can easily say that below the 300 level it is a dark condition, and above the 300 it is the light condition. Okay, so simple. We can just fix our threshold value as 300, and then rewrite our code again. Okay, then here I define our threshold value, threshold or TH. Here I just paid 300, or you can write 350, no problem. Okay, fine. And in the loop section I just write if analog read this LDR pin uh, will go under the threshold value, that means uh, the circuit in the dark condition. Any doubt about that? I think no. So here if we just write digital write LED high, that means under the threshold level the LED just turn on, and otherwise the sorry, digital write here, to copy again and just print it here, and instead of right, you can say low. Okay, fine. Then we can easily tell the value. If the value under the threshold level, then it is the dark condition, it is the dark, and over there it is light. Okay, it is light. So if you just hit the upload button, and okay, code uploaded successfully, then in this condition you can see this is the light condition, and our LED remains off. Then if we just hide the light from our LED, the LED turn on. Okay, very interesting. And we can learn how to use LDR and how to deal with the light, presence of light and absence of light, and from that we can easily make a dark sensor circuit. It is simple. You can use you can build the circuit without Arduino, but mainly our focus to learn the Arduino, so that's why we made the circuit. And let's go ahead.